Hi, good morning everyone. My name is Rohit Marakoti. Today we will be discussing about the topic which is very familiar in the IT side. We can able to say how we can able to build the application faster and we can able to scale the deployments and also improving the performance optimization. So that is the topic which we will discuss. The topic name is a framework for rapid development, scalable deployment, and performance optimization of cloud native healthcare applications. That's what we will be discussing today. So how exactly we can able to achieve that is where this topic will start. For the introduction, if you will ask me, like how we can able to do the rapid development. Nowadays, everyone is trying to build the applications in matter of minutes. So how quickly we can able to launch this application is something through the AI models. By building these AI models, we can able to launch the application pretty fast. So that's where we will be discussing on today's session. So first is if we will know there are in the BPM space there are multiple applications or multiple tools are there which we can able to use. One such tool is Pega. Through that we can able to use this rapid development by using the Pega blueprint. Pega Blueprint is the newly released product released by Pega itself, Pega Systems. So what exactly happens here is whenever we will give a requirement, set of requirement is provided in the first screen itself. That point itself, it can able to capture the requirement and it will ask set of questions for us, what is the sector you want to build this application for, and then how many users, and there are several things you can even give the persona, what kind of users wants to log into the system. Then it can even give several suggestions. Basically how it starts is very first thing itself, we need to provide the requirement. Once we gave the requirement, from that point application can able to understand, and this model, these LLM models which are will run behind the screens will try to understand and come up with a case types. What is the definite case type needed, and also it will come up with a different data type models, what are the data type models we need to build for this application. So those kind of information it will start providing. So mostly if you will see, it's like a screen flow where from one flow to one screen to another screen, where you have to answer some of the questions based on the requirement you have provided. From there itself it will go to the next screen, and then it will start giving you the suggestions on what kind of case types needed for this application. Then you once if you will choose that, then it will go to the next screen where you can able to see the data types, what are the list of data types need to be built for this. Then it also asks several questions what kind of personas needed, what kind of users accesses need to be required for this application. So those kind of information will be provided by the blueprint product itself. So in general, if you will see um earlier, if you will see to build any application, it will go from um to build a MVP product, right? It will go from anywhere from 6 to 8 months. Now the period has drastically reduced to less than a month. Also, we can able to achieve these kind of things. We can able to achieve through these AI models. As I mentioned, using the blueprint is one such through which you can able to launch the application pretty quickly. The advantages wise, if you will see, this is one of the rapid development where you can able to launch the application next day. From there, you can able to you know like from there you can able to make the users work on this application, and this application will be hosted in the cloud itself. That way we don't even need to manage the servers, databases, or any networking settings. All those kind of things will be managed by the Pega systems itself by using their cloud partners. So that way what is happening, so building the application will happen pretty fast, and very rapidly we can able to do that. But the disadvantages wise, if you will ask me, one thing is like definitely customizations. So you cannot do more and more customizations through this product. And also, if you will think in developer perspective, these applications are building so rapidly, and this is building by itself, right? Meaning like the code is generating new code to build this application. And so since like this is something developed by the code itself, to understand and debug the issues in the production, or else to debug these defects, right? So those kind of things will become more challenging. So definitely there might be tools which need to come for those as well, which will able to help to fix those debugging in faster manner. But if you will think in developer perspective, like definitely that is something the developer have to take. And then like UI also, right? Since most of these applications might be used for back office users, um, meaning like the users whomever will be there for suppose if you will take the financial sector, where this dispute claim manager users will be there, who will be processing the disputes. Those kind of users can able to use these applications. So pretty much like employees of that same company will be working on this application. So that because of that, like the need of excellent UI, or else like need of attractive UI is really not required. So rather than that, a lightweight tool with more automated flows can able to achieve through this product. Um, how we can able to achieve means definitely like using the schedulers and then like queue processors. There are several of the advanced tools or rules in Pega, which we can able to use it to process the data much faster way. That way, like like there are several of the tasks can get automated. That is the main advantage of using these tools. Um, and then like if you will ask about the agentic AI, right? So this is exactly what will happen in the agentic space as well. Meaning like once if we will see the users, whomever will be humans working on those applications, can gradually be given to the agents or bots, who will be like a robots who will be working on this application, and then they will be doing the processing work. And those agents will be more matured and like human centric in nature. That way like they can able to understand and try to solve the challenges in a humanistic manner, rather than like try to like do the set of tasks. They can able to understand and analyze and come up with the better solution whenever it's not something really not there in the uh, code or conditions. So those kind of things we can able to achieve that way. Like one, like you can able to build this application pretty fast. Two, then like from that point, like how much ever we can able to do the automation to make the this application work independently without the human intervention. Those kind of things also we can able to build using these tools. And then the second part of this topic is related to scalable deployments. Uh, think about this, like where the application is built now in the development region. Now you have to promote it into the production region. But there are several regions in between where you need to have the regular testing should be needed, and then regression testing should be required. So those kind of things we have to do, right? So how can we able to achieve that? And then like how quickly we can able to build this application to promote to next regions. For that, there are several deployment manager tools are there. What happens is through these tools, right? So we can able to pinpoint the region 1 to region B, and then like you can able to connect these pipelines. That way like the jar file whatever get created in the development region can able to trigger and move it into the next environment. So those kind of pipelines can able to build as well, and that can be built in the same manner, like in fast phase manner, compared to the way how we will use the legacy languages, right? So that get changed eventually. So what happens is like all we are trying to do is So these pipelines, whatever will be there from one region to another region. So you need to set the pipeline with the respect to access groups, and you need to provide the security settings such a way that only specific users can able to do deployments, meaning like they can able to trigger the pipelines so that the deployment will go from one region to another region. So that can be able to that can also be achieved in the settings of the deployment manager portal. And then so once the deployment is moved from one region to another region, suppose if it is the code package which is in the staging region, now it need to move to production means, so we can able to set some conditions, meaning how much is the code quality there, what is the overall code score, like guardrail score, whether it is 90% or 95%. So those kind of scores can able to we can able to see. And also like you can able to restrict if the code is something lesser than certain percentage. So that way, like what happens, we can able to migrate the good quality code to the production region. That is one thing we can able to do. And on top of it, whenever these deployments will happen, right, definitely we need to have the leadership aware of these deployments. So to do that, like you can able to auto generate these the emails which will trigger and go to the inboxes of the managers or supervisors, whomever will be there. And all they have to do is they can have the options in the Outlook itself, whether they can able to approve it or deny it. So those options we can able to configure such a way that the managers doesn't even need to go into the deployment manager from their outbook Outlook itself. They can able to approve it, so that the mail get triggered through the APIs, and immediately the deployment will happen. So that those kind of features also you can able to achieve using this particular deployment manager. Uh, so here, if you will see, building the application is one one phase, and the other phase is using the scalable deployments. That is something in the another phase. So once if we can able to deploy into the production region, and then if you need to scale it up, now if you will see the number of users whomever will be there for the application, if will be very limited when it is in the development region. Whereas if it will go into the production, if you have a complex system where this will be used by multiple users, thousands of users will be there for this application, and these application users will be residing in several regions across the USA. So how we can able to scale this such a way that the the overall performance of these applications shouldn't go down, right? Meaning if the code is just resetting in one specific region, these kind of issues might occur. So based on the reasons also, we need to spread across the code, meaning what you are trying to do is you make sure that the servers will get connected with the users whomever are in the nearest region, such a way that there will be lesser traffic and also lesser networking latency issues. That way you can able to scale these applications pretty fast, and also so that this can go so that you can see this can be used from the day one by multiple thousands of users. That is the advantage here. And the third point is performance optimization, right? So if we will talk about the optimization again, so what happens here, there is some performance issues might occur for any of the application. Suppose if you see these performance issues, how we can able to overcome or fix those issues, whether it is in the lower region, how to detect that, and then whether it is in the production region, how we can able to identify those kind of things we need to see. Suppose if the application which is there in the lower environment, which is not yet deployed to production, that point what we can do is there are several testings will be there, performance testing will be there, regression testings can be done. That way you can able to identify if there is any latency issues there in the application in any of the screens, and then try to fix those screens. So those kind of things you can able to achieve it. whether by adding the indexes to the database tables, or else building the report definitions with highest quality. That way, you can able to make sure that the application is still maintaining the lightweighted, such a way that you don't see the latency issues once it get moved to the production as well. That is one way you can able to achieve. And there is another thing, right? So where the application now went to the production region, and in prod, like where the users are facing the issue, then like you have to come up with the solutions which are shouldn't be breaking the existing system. At the same time, there will be some level of improvement you can able to bring to the system. So those kind of things also we need to look into the we need to take into consideration when we are building this application. Some of the things like checklist, right? So which we need to identify and formalize it in the very initial phase itself, so that how many of the users are there, and then like based on the users and how many our needed servers. So those kind of things, if we will know in the initial phase itself, then we can able to build the application. And then by keeping these numbers in mind, we can able to achieve that as well. And always it's a good practice that whenever you are building this application on any of the browser, right? Suppose if the users are using Google Chrome browser, then always um, the application should be built and tested in the same browser, rather than they will be testing in the testers will be testing in the different browser, whereas the users will be using some other browser. Those kind of things you can able to avoid, such a way that there will be some level of improvement will be there. And then we'll see what kind of um, applications we can able to build. And there are several AI models also there, right? Through which you can able to process the data pretty quickly, such a way that uh, the decisions can able to take much faster. One such case type is we can talk about oncology care, meaning using the AI to predict the cancer. So that's something we can able to achieve by using these AI models. Um, in this case type, right, whatever I am explaining, so we'll see like what kind of models we need to use, and then how exactly we can able to leverage these AI models to predict the cancer, such a way that it would be like a something really required for the society. And knowing the cancer upfront will make them prepared to prepare themselves, right? Patients get prepared themselves and have some treatment, such a way that the lifespan will eventually increase a lot. So that is something we will see in this session as well. So just to know the overview about the cancer, as I was saying, like there are around 18 million people are affecting with cancer every year, and in that, almost like 9.5 millions are dying as well. So these are the big stat numbers, right? Where you can able to see like several of them are also dying because of the cancer, and it's a deadly disease for sure. And if you will see the cancer itself, the nature of the cancer itself is uh, doesn't provide a single solution, meaning you have to come up with multiple solutions for each of the cancer type. So definitely we need to have a system where identifying the cancer, with not just with one system, need to be with different systems can able to be built as well. How we can able to do that? Definitely by using the AI models. AI models will definitely help, right? So if we want to predict something, definitely we can able to um, use the AI models. And if you want to scale that up, like for multiple users, suppose if you will see like several millions of people are affecting with cancer now, that ratio, if we will compare with the number of hospitals and the faculty really there to support them, might be less. So what we need to do here is we need to use technology in this space to come up with some solutions that can able to fix the problem here. That is one thing. And then like other part is also right. Misdiagnosis will happen in the cancer field a lot. Meaning like suppose if the patient whomever will be there, they will get treated with one set of biopsies, and after having several rounds of therapies, so what happens, then they will identify that whatever the chemotherapy we are giving might not be helping the patient to solve the, might not helping the patient to kill the uh, tumor. So at that point what will happen is the doctors or providers will look for the secondary options, meaning like it's like a misdiagnosis will happen in the cancer. So those kind of things we need to understand and we need to fix those as well. And the third part is generic treatment plans, right? Meaning like currently if you will see most of the patients who have got cancer, they will go with the generic treatment. There is no precision care, meaning like a personalized treatment for the patient is not there. But definitely that is also required, because like if you can able to provide a personalized treatment for the patient, that way you know like you can know more about the patient, and giving a better solution will make the patient to like solve the disease much faster compared to a generic treatment for everyone, whatever the cancer it is. So those kind of things are some of the gaps which we are seeing in the healthcare system, for especially for the cancer side. To fix that one such as I was telling, like these three problems, right? Early cancer, early detection of the cancer, and then misdiagnosis, and the other one is a genetic treatment plan. So we will be discussing a couple of the research papers where like how we can able to achieve identifying the early cancer using the AI models. So what we can do is like we can able to build a medical imaging analysis pipeline. So these pipelines are something will have couple of stages, like four stages we can say, like a AI powered image processing stage, tumor segmentation stage, future extraction with GLCM stage, and the machine learning for classification stage is there. So now in each of the stage where like uh, where like set of things or tasks will be performed, and finally like by the time it will go to the machine learning for classification, we can able to see that the product, or we can able to see that the results whatever we got should be able to identify the tumor. Right. So for that, so in the very initial stage of AI powered image processing stage, all we have to do is when we are inserting the images, right, images of these tumor cells. So we need to, we need the system has to scan it and then undergo a minimal filtering, right? Filtering to reduce the noise, and then like overall enhance the contrast of the images. Those kind of things will perform in the initial stage one. So from there, like in the tumor segmentation stage, the system can able to isolate the tumor, meaning like there will be several tumors will be there inside the body, meaning like um, some of them are nervous systems of the human body which are healthy, some of them are tumor related, right, cancer related cells will be there. So now that the tumor segmentation should be a very important step where the system should identify or pinpoint, saying that this is something we need to look into, meaning like this particular tumor might be something different from the existing other tumors. So that's where like we need to spend an extra amount of time. So those kind of things you can able to do in this specific stage. In the GLCM is a technique which you can able to say it's a gray level co-occurrence matrix through which you can able to identify the contrast and correlation and energy of the tumor, and then homogeneity of the tumor, right? So those kind of information you can able to get from that point, like you can know like whether this tumor is something cancer related or else if it is not. Those kind of information you can know. Once you get all of this information, that's where like you will start running the AI models. Usually we have like a SVM model and then ANN models are there, which is like a support vector missions and then like artificial neural network models, right? These are the two different models are there. But what we can do, like if you will see SVM model which are used for only for basic tumors, meaning like if there is anything with limited capacity, you can able to use the SVM. Whereas if there is anything with the complex capacity means, then we will go with ANN models. So by using these two models, we can able to achieve much faster results as well, meaning like you can able to um, predict the cancer pretty much well. That's what it is. Okay. So as I was mentioning about these four steps in the pipeline, right, through which how we can able to detect the cancer. So from that point, like there is a good amount of accuracy rate is there by going in this approach compared to the existing manner. So that is one way, like you can able to say like using AI models can able to predict the cancer in the early stages itself. By the time the tumor get created, the system can able to identify, and then like once it get enlarged and start spreading throughout the body, before that itself we get to know means, then we can able to give the precision care. Meaning, see, like there is a study which came up, whenever a patient who is in the level 3 or level 4 of the cancer means, usually the best approach is to go with the general care. They will just go directly to the chemotherapy, or else through radiations they can able to try to like kill the tumors, cancer tumors. Whereas if the person who is in the very early stages, then going with the precision care is much better approach. That way you can able to identify the tumor, you can able to like you can able to give a personalized treatment that can able to solve the problem for the patient, and at the same time it doesn't affect the other uh, networks, other neural body in the body, right? So those kind of things we can able to do it as well. So Yeah. So what happens here is, if you will see, if you will talk about the precision care, right? Precision care really is required because of various reasons. One is if you will see the biomarkers of the body, which will be completely different from one body to another body, uh, and we need to understand that upfront before even going with the treatment. So, and also like when you say the personalized treatment, right, we should know the habits of the person as well, whether the person is having smoking or else like what kind of diet they are taking, and alcohol, whether they are taking or not. So those kind of information will be helpful, so that like we can able to see like whether the cancer related chemo, right, whatever we will provide, so whether it can able to fight with the tumor cell, or else like so we need to have a stronger dose, or we need to come up with a different approach. Those kind of information we need to calculate and see upfront before even going directly on the treatment, right? So so to do that, we need some level of prediction. That prediction can able to done in the precision care, or with that result you can able to go further to see like whether this person should be treated with the results we got from the AI model, or else like so those kind of discussions will eventually happen, it seems. So that's what. So overall, like when we ran into several of the models to understand which model will be better for precision care, so what we have identified is XG booster model overall will be performing better compared to the random forest model. That is one uh, findings we have seen. And the second finding is, as I was mentioning, like whenever a care is given for a patient who is in the level 3 or level 4, it's always going with the general medicine is much better than the same person who is in the level 1 or level 2 can go with the precision care. That is one advantage. And there is another finding where we saw that there is almost like 5 years of survival rate will get increased if the person will go with the precision care and then getting the treatment done rather than going with the standard approach. So yeah, so definitely like precision care will be definitely helpful for any of these patients. Okay. And now that we have discussed about the overall building of the application and running these models such a way that effectively you can able to move the data from one system to another system seamlessly, and then like how we can able to deploy the code using the deployment manager, uh, and then like we also discussed today about the overall performance optimization, right? So what is the best approaches to optimize the data? Those kind of information also we have seen. um, so if there is any questions or something, feel free to reach out to me. As I told, like my name is Sai Rohit. You can connect with me through LinkedIn as well to discuss on this topic further. Thank you so much.